So in this clip, we're going to take apart this integral here and rewrite it in the other 5 possible orders of integration. So step 1 is decoding the integral. And I like to, if I don't see anything that jumps out at me, start with the outside first and work my way in from there. So the first thing I see is that x lives between 0 and 1. So if we're thinking this is the x y plane, then that's telling me that, you know, everything is going to be in here. Okay, and so I can just kind of narrow it down until I can see what my region is. So then my next step would be to, let's see now. And so, by the way, I chose to do the xy plane because I'm looking at kind of the outermost thing that happened here. And so then the next thing that I'm going to be looking at is what goes on with this one here. So we're going from y equals root x up to y equals 1. And so let's see then. So y equals 1, that's this one, y equals 1. And then y equals square root of x, that's going to be this part of this parabola right here. So that's y equals root x. Okay, now that I have some idea of sort of the footprint of my region in the xy plane, or more generally, the plane spanned by whatever the outermost 2 variables are, then I can set things up in 3D and look for the last one. So here's x, y, and z, and let's see, so I've got something that's parallel to the x-axis out here, and it's got some sort of parabola bit coming like that. I don't know if I like that picture. Here we go. There we go. Slightly better. And then the last thing that I see is if I look in the last equation that I have to deal with, so I go from z equals 0, so that's the xy plane, up to z equals 1 minus y. And so that's going to be this plane. Let's draw it in purple. So it's going to include the line here, and then it's going to be as if I attach that everywhere. So let's see. So it's going to be like that. Maybe that was a bit thick. Well, maybe that's a little thin. Who knows? Okay, I can't get myself a Goldilocks paraboloid to save my life here. Oh, no, sorry, not paraboloid, parabolic cylinder. Anyways, so that plane right here, this is the plane z equals 1 minus y. Okay, so now I've got some idea of my region, and let's see, I can go about figuring out what to do for setting up this integral in the other ways. So first off, I guess the easiest thing to do is the one that leaves the dz on the inside. So then I would need to figure out how to do it dx dy. And for this one, I only actually need to look at this part right here, just set it up in the other order. So let's see, so if I have, there we go, that guy. Then let's see, so instead of doing y first, I'm going to be doing x. So so there's my going in the dx direction. That's x, it's y. So let's see, so x starts on this surface here. So that's where x is equal to 0. And then it's going to come up to this one right here, and that's formed by y equals root x. But since we're doing the x integral, we want it in the form x equals, so this is x equals y squared. So it'd be a y squared. And then I can tell that, let's see, so what happens when I'm done? We're going to take y through 0 up to 1. 0 to 1. Okay. So there's one rewrite of the integral. Now, in order to understand what's up with this object here, so I'm going to actually draw it slightly more neatly. Let's see, like that, like this. Down, and then, oh, beautiful, look at that, picture perfect. Okay, that's what I was hoping for. So when I have this, let's see, if I'm going to integrate it in some other order now, I need to figure out what it's going to look like after that projection. So suppose we do the dx first integral. So this is where dx is in the innermost. So I'm going to set up f dx and then do the stuff outside there. So in this case, this is the x-axis. Let me just label these guys real quick here. So after doing in the dx integration, I'm going to be seeing a projection to the xy plane, or sorry, to the yz plane, and it's just going to look like a triangle, because I'm going to be seeing this this purple plane here. I'm going to be seeing that end on, like right from the edge. So let's see. So we've got, there's our YZ triangle, and let's see. So for the X integration, what does one of these things look like? So it's going to be coming through the object like this, and it'll hit in the triangle, and then it'll hit in the parabolic cylinder as it comes out. So if I was over here, it would be real close together. If I were here, puncture here would leave over here, so on and so forth. So I need to go from that back wall then, so that's apparently x equals 0, and then I'm going to be coming out through that surface there, and that's going to be given by the x equals y squared surface, that parabolic cylinder. Okay, so there's that guy. And then let's see, so now let's do I guess dz dy. So if we do dz first, then we're going to be integrating this way, and so we're going to go from z equals 0 up to z equals 1 minus y. So I go 0 to 1 minus y, and then I'm going to pick up 0 to 1 for y. I could also do, let's see, so the same one with the dx first, and then I could do dy dz, and then this means I'm just going to be going dy first, so that's horizontally this way, and in that case this bounding curve is y equals 1 minus z. So I've got 0 to 1 minus z, and then 0 to 1 again. Okay, so there's those two. If I were going to do dy first, then let's see, so I'm going to go f dy. For this one, let's see, so then I'm going to be projecting this way after doing a dy integration, and so it's going to be left over in the xz plane, and the thing that I'm going to draw here is going to be the shadow of this red curve right here, so it's going to be something like that. Okay, so now what actually is that red curve? Well, that's going to come from, let's see, I've got on the one hand y plus z equals 1, that's my the slanted plane on top, and on the other hand I've got y equals root x, and so I'm going to combine these together, and so that'll give me root x plus z equals 1. So I might solve this as z equals 1 minus root x, or as let's see, x equals 1 minus z quantity squared. Okay, so so let's see, so that's, again, just for reference, this is the x z plane. It's that curve right there. Okay, so let's see. So I'm going to do the dy integration first. So for a dy integration, we imagine line passing bam through the object coming this way. Maybe there's enough crud in here that I should like clear up some of this mess at this point. Okay, there we go. So bam comes shooting through here in the y direction. We're going to hit first on that parabolic cylinder and then on that slanted plane as we pass out. So let's see. So we go from cylinder to slanted plane. Okay, so that's just sort of to organize my thoughts. So cylinder is going to be y equals, I guess, root x. And then the plane is going to be y equals 1 minus z. All right, and now we proceed to setting up this little funky region. So let's do, I guess, dx dz. So if I'm doing dx dz, we're going to be going dx first. And so we're going to start definitely at x equals 0. And then we're going to end here at x equals parabolic thingy, which I just solved for right here. Okay, so we go from 0 up to 1 minus z quantity squared. And then you can see that's going to be from 0 to 1. Or we have, so this is also equal to root x to 1 minus z f dy. And if we were to set this one up going the other direction, so where we go vertically here, so we're doing a dz integration, then we're going to start down here at z equals 0, and we're going to go up to this one, which is apparently this guy here, z equals 1 minus root x. So we go from 0 to 1 minus root x, that's dz, and then dx is going to be 0 to 1. All right,